Previously, I wanted to shoot some videos of water droplets flowing backwards and standing waves, so I needed a strobe light. However, I found that most strobe lights on the market have a frequency that's too slow, like those in nightclubs. This resulted in my water droplet reverse videos having a flash frequency that was too slow. So I decided to make one myself. Hello everyone, I'm Wonder Maker. Welcome to my channel. First, let's look at the finished product, powered by a Type-C 5V supply. An OLED display shows the current status. The joystick controls the flash frequency up and down. Click to randomly switch to a color. Long press to restore the default white. Joystick left-right switches among the last 20 colors. Equipped with 64 LED outputs. Overall, it meets my needs for filming small experiments. Now, let's start today's making tutorial. First, we need to prepare the following items: an 8x8 LED module, a joystick, and an Arduino Nano main board. A Type-C connector and a 0.96-inch OLED screen. Wiring can be a bit complex. I recommend using Dupont wires with a breadboard to resolve connection issues. Let's introduce the two new modules, the joystick and the OLED screen. If you want to learn about the modules, pay attention to this part. If you want to skip to the making process, feel free to do so. Joystick module, essentially, it's a combination of a switch and two potentiometers. Besides the power pins VCC and GND, it has three more, VRX, VRY, and SW. We can consider these as two analog switches and one digital switch. When installing, don't worry about the orientation, you can adjust it on the computer. The OLED screen is a small organic light-emitting diode display. Typically, there are two types on the market, SPI and I2C interfaces. SPI connections are faster and can support touch, requiring 4 wires. I2C connections are slower, usually one-way transmission, needing only 2 wires. Due to the fewer pins on small chips and slower computation, and because small screens rarely use touch, I2C is more common. The most common combination is the 0.96 OLED I2C screen plus Adafruit_GFX library plus Adafruit_SSD1306 library. It's very convenient to use. Making process. Step 1. Connect the joystick to the Arduino. Copy the program code in the details section. Test the joystick to confirm the outputs for up, down, left, right, click, and long press are correct. The code is adapted, so it won't fail to execute if only part of the modules are connected. The joystick's up-down response is quick because it adjusts the frequency range. Step 2. Connect the OLED screen to the Arduino. Restart the device and test the joystick again to check if the display is correct and if the screen refreshes. Step 3. Connect the LED module. Restart the device and test the joystick again to ensure the LEDs flash correctly. Step 4. Connect the Type-C power cable to the device, with VBUS connecting to the positive and GND to the negative. At this point, all electronic modules are complete. Next, let's print a casing for it. The model link is in the details section. Following the principle that, if I solder it shut, it must be removable, all connections are detachable. I'm using round head pins from the small model. The installation steps are as follows. First, wrap any excess pins to avoid short circuits. Next, secure the Type-C connector. Place the LED board. Use pins to secure it. Use the same method to secure the OLED screen. Secure the joystick. Finally, stuff everything inside. Put on the back cover and you're done. After plugging in the power, let's see the effect.